Chapter 13, Dimensionalism and the Continuum Hypothesis. This topic may seem obscure to the normie, and to many readers the Continuum Hypothesis may seem like such an underwhelming topic to follow the meanings of life. But I can assure you, the concepts here in this chapter are so obscurely taught by mathematicians because it is essentially a philosophical matter. At best, the philosophers only have this hypothesis, which is more of a null hypothesis, to explain this big gaping hole that is at the foundation of mathematics. Let me explain. The continuum hypothesis states, in my own words, that the quantitative dimension commonly known as the number line is connected and continuous all the way up to the largest infinity and down to the smallest infinitesimal. The continuum hypothesis is really a null hypothesis in mathematics, that there really is the smallest distinguishable negative infinitesimal, followed by a true neutral zero, followed by the smallest distinguishable positive infinitesimal. And the continuum hypothesis proposes that this level of continuity does occur for every number. It is the simplest solution to the matter anyway. For the normies, the mind-blowing part comes when the opposing / more convoluted hypothesis is presented as being just as valid, unknowable, and indeterminate to mathematicians. That is, that there can be up to an infinite quantity of infinitesimals that are missing from the number line. Using dimensionalism terminology, this opposing hypothesis would be put in the form of the following questions. 1. What if everything was really all there is? I say, no, omega everything is all there is. The opposing hypothesis is only that which is finite truly exists, so just everything. 2. What if omega everything does not exist? I say, of course it exists. Infinities show up all the time. The opposing hypothesis is that of pure finitism. 3. What if zero only exists imprecisely, it is never absolute? I say, if there is no absolute zero, there is no true neutral charge or number. A literal nothing does exist within philosophy, that is nihilism, within mathematics, that is zero, and within physics, that is the empty set universe of the multiverse and the zero-dimensional point. The opposing hypothesis is that only zero the finite exists. All we ever see is zero the finite, after all. 4. What if there is no infinity? The theory of nothing states, now just you wait a cotton-picking minute. If all you ever see is zero the finite when I write zero, why do you choose to remain so obtuse to see no infinity when I write infinity? Infinity exists right here! On the page, not here. The opposing hypothesis is so convoluted and discontinuous in logic, it should just be thrown out entirely. Of course there are no gaps in the number line. It is a line. It is one-dimensional. Dimensions are straightforward. No ifs, ands, or buts. Space is infinite. For example, give a coordinate at the edge of space from your perspective, the number 111. Okay, gotta picture it. If this direction is y, if that direction is x, and that direction is z, there will be some coordinate out in that direction that is 111. The distance to that point will be about 1.73. Like, if all we can see of the observable universe are points that are exactly distance 1 away. If you plotted the point 111, that the distance to that point would be equivalent to 1.73, which would be outside of the observable universe. We can keep that point well defined, but we cannot truly know that the point exists. If you say it does, then recalibrate the XYZ axis to this new point and keep on looking for the point 1.73, 1.73, 1.73. Eventually, you will reach a point in space that is so far away that you would have to concede that some point in space is infinitely and unknowably distant from us, even from your flawed finitism philosophy. But the honest answer for mathematicians is that nothing about math would fundamentally change if those gaps actually did exist on the real number line. Numbers and the number lines that are constructed by us are fundamentally imaginary and subjective constructs. It is zilch and nada who make these numbers real in the first place. Zero is the starting point for both imaginary and real numbers. Zero is equal to 0i. but 1 is not equal to 1i. So anything that is something is not imaginary unless it is defined as an imaginary somethingness. 1i is equal to 1i. So now with this conjoining of my null hypothesis and continuum hypothesis, I am now ready to show you how to make 1 plus 1 not equal 2. First, we need to give our personal definition of everything some known parameters. Let's say that we cannot know anything beyond 9 digits away from the decimal point, where our definition of everything goes up to 999999999.999999999. So to be precise, we will fill up all of these digits for this very simple equation, and I'll leave the zeros out for this. 1 plus 1 equals 2. Now pretend that we have an alien species that is slightly more advanced than us. Their parameters for everything cannot go beyond 10 digits away from the decimal point. So they can count just to a billionth of a decimal place away shy of 10 billion. They take a look at our meticulous equation and they say to us, hey, I'm not so sure this is correct. I mean, it is fine from your measly human non-nary digit perspective, but from our superior alien denary digit perspective, you could be wrong. Look! 1.00000000004 plus 1.00000000004 equals 2.000000008, which we both know can be reduced to your non-nary form to be 1 plus 1 equals 2.000000001. This can be further reduced to say that 1 plus 1 equals 2.000000001. So to the finitists, I say, if infinity doesn't exist and the infinitesimal doesn't exist, then what is commonly defined as being an integer also doesn't exist. 0 is an integer, a whole number. 1 is an integer, a whole number. So a more precise definition of an integer that is congruent with the common definition is a number that only has zeros after the decimal point. An integer is not just a number that is not a fraction. This impreciseness of integers is precisely why the indeterminate form of 1 to the infinity is not just 1, but 0, e, and infinity as well. And if these integers are imprecise thusly, they are not whole, but are made up of an onslaught of indeterminate infinitesimal fractions as well. In other words, we cannot say that we know a number is whole or an integer unless we define it in such a way that all of the decimal places are in fact 0 infinitum. And nobody knows that. But again, even if there were an infinite amount of infinitesimals missing, the current understanding of mathematics would not fundamentally change. For most to all intents and purposes, 1 plus 1 will still equal 2. But if this impreciseness of the integer is congruent with the reality of quantitative methods, regardless if there are gaps or a continuum, we are still left with an intriguing dilemma. The solutions to Grandy series would be left as a broader range of possibilities than usually contemplated. Grandy series is the infinite series of 1 minus 1 plus 1 minus 1 plus 1, and so on. If we determine that the placement of the odd ones are of one type of 1, and that the even ones are of another type of 1, the value of the series could go beyond the usual parameters of 1 and 0. I know, this past sentence sounded like utter nonsense, but bear with me. If we use the indeterminate form of 1 to the infinitieth power to say the value of 1 to the infinitieth power for all of the even ones of the Grandy series is 0, but the value of 1 to the infinitieth power for all of the odd ones of the Grandy series is infinity, then the solution to the Grandy series would likewise tend towards infinity. When the scenario is flipped, the Grandy series would tend towards negative infinity, but the center of the series as a whole is not 0, nay, it is 1/2. Even when we leave the impreciseness of the 1 to its own devices, where we cannot define two different sets of 1s, the emergence of sets breaking below 0 and above 1 should still be common enough to say, hey, if this known set repeats itself as is infinitum, the infinite repetition of this known set would tend towards an infinity. 0 and infinity give us weird counterintuitive solutions to everything. So whenever you see them, beware. 0 plus 0 plus 0 plus 0 for an infinity can give us something. Another way that something can come from nothing.